This algorithm directly optimizes for user-perceived latency. But it does come with slightly more overhead, as the load balancer needs to perform health checks to gather that timing data. The choice between them is a trade-off between a good proxy for load and a direct measurement of it.
So far, we've assumed our requests are stateless. But what about applications that require session persistence, like a user's shopping cart or a multi-step form? If a user gets bounced between servers, their session data is lost. This is where hashing algorithms are essential. With IP hash, the load balancer creates a hash of the client's source IP address and uses that hash to consistently map the client to the same server. Every time that user connects, they're sent to the same place. It's effective, but has a flaw. Clients behind a corporate net or a large proxy will all appear to have the same IP, causing them all to be sent to a single server, creating a hotspot. A more granular approach is URL hash, a form of Layer 7 load balancing. Here, the load balancer hashes a component of the URL. This is incredibly powerful for caching. For example, all requests for /images/product123.jpg can be hashed to the same server, maximizing cache hits. It ensures that requests for the same content go to a server likely to have it cached, dramatically improving performance for content-heavy applications.
So, which algorithm is best? That's the wrong question. The right question is, which algorithm is best for my specific use case? Your choice is a function of your system's constraints and goals. Start by asking, are my servers homogeneous? If yes, simple round-robin might suffice. If no, weighted round-robin is your starting point. Next, is your application stateful? If yes, you must consider a hashing method like IP hash for session persistence or URL hash for cache optimization. Finally, what is your primary performance driver? If it's about preventing server overload in a dynamic environment, least connections is a robust choice. But if every millisecond of user-perceived latency is critical, the overhead of least response time is a worthy investment. The takeaway is this: understand your traffic patterns, your server capabilities, and your application's architecture. Load balancing isn't a one-size-fits-all solution. It's a precise engineering decision that reflects a deep understanding of your system. Choose wisely.